Okay, so the same concept can be applied to polynomials, not just monomials. So before you can apply it though, you have to factor each polynomial so that you can figure out like how many of each factor there are. Okay, so this first polynomial, go ahead and factor it. We've done a lot of practice on factoring. You do what multiplies to AC and adds to B. And so I get x plus 3, x minus 1. Okay, this other polynomial, let's go ahead and factor this one. So I'm going to go ahead and I get x minus 4, x plus 3, because negative 4 times 3 multiplies to negative 12 and adds to negative 1. All right, so remember, the same concept was you look at each factor, okay? You go for the highest amount between the two, okay? So let's just start with, I just pick one to start with. And let's just go ahead and I'm going to start with x plus 3. X plus 3 happens here, and x plus 3 happens here. Each just happened once, so you can kind of think of it like they're tied, so we just use it the one time. All right, x minus 1 happens here, but over here on this set of factors, x minus 1 did not happen. So happening once versus not happening once is the most, so that's what we use. All right, now look at the x minus 4. It happens once from the right polynomial. It doesn't happen from the left polynomial. So between the two, the most it happens is one time. So this is what we would have for our least common denominator if we were doing some type of math problem and these were our denominators. All right, let's try again. So your first thing is to factor. Go ahead and think about how you're going to factor this first polynomial right here. All right, what multiplies to 25 and adds to negative 10 is negative 5 and negative 5. So it's x minus 5 times x minus 5. We're going to write that as x minus 5 squared. All right, now do this one. And so you're saying, okay, what multiplies to 45 and adds to negative 14? That would be negative 9 and negative 5. So x minus 9, x minus 5. Okay, so you compare each factor. So x minus 5, it happens over here on the left side, x minus 5 squared, so its degree is 2. Here, it's just x minus 5, so it happens once, its degree is 1. You want the one that happens the most, so we're going to use x minus 5 squared. Now compare x minus 9. It happens here once. It doesn't happen from the other polynomial, so the most it occurs is the one time. That is going to be our least common multiple. Okay, back over here to this one. So I have x plus 4. Okay, that can't be factored, so I literally just have x plus 4. Now let's factor this one. What multiplies to 12 and adds to 7 is 3 and 4. So x plus 3, x plus 4. So compare each factor one at a time. So first I'm comparing the x plus 4. It happens one time on both sides from both terms, so I'm just going to have it once. And then look at your x plus 3. It happens one time on the right. It doesn't happen on the left, so the most times it occurs on either side is just that one time. That's your answer. All right, last but not least, let's go ahead and factor both of these. This one factors 2. Let's see, multiplies to negative 6, adds to negative 5 is x minus 6, x plus 1. And then over here, this one is going to be what multiplies to 3 and adds to 4. That's 1 and 3. Okay, between the two, start with x minus 6. It happens over here on this green one once. It doesn't happen over here on the pink one. So the most it happens on either one is the one time. Okay, x plus 1, it happens one time on the green and one time on the pink. So the most it happens on either one is just the one time. And then x plus 3 happens once on the pink but not on the green. So the most it happens between the two is just that one time. You just are comparing them and you pick whichever one occurs the most. I think of all of these, the one that to me makes the most sense when you're really looking at it is looking at this one where we had x minus 5 squared compared to x minus 5 and really able to see that x minus 5 had a degree of 2 and happened the most times here. And so we chose that one versus x minus 9. I think it's more obvious to see when it has a repeating factor. I just think it's a little clearer. So we're going to practice this on the worksheet so that tomorrow, or I'm sorry, next time when we get together, we will be able to use this skill on doing something that is applying it to Algebra 2.